Today on the bench we have a Yaesu FT-950. So this is a HF and 50 megahertz transceiver. Was sent in for a repair, and I'm not going to be turning this on until I do the repair because I don't want to let any magic smoke out. So, what happened to this poor thing? Well, the customer decided he wanted to do a Mars mod on this, which is a fairly simple modification. Pull the bottom cover off. Now, most places you'll read, bridge with solder across two pads. Actually, what you're supposed to use is a 0 ohm jumper resistor, which is what I will be using. But in any case, he went to do that and apparently melted the ribbon cable, or one of the nearby ribbon cables, little flat flex cables. So actually, it should be, I've already pulled them out. It should be one of these. These are actually brand new Yaesu cables, but apparently one of these critters, it got nuked. So I frequently say in my videos, get out there and work on your own radio. For starters, you'll save yourself money. You don't have to send your radio to somebody like me to work on it. There's a lot of things you can do to your radios yourself. But you'll also, at the same time, hear me say something, practice, practice, practice. Radios like this are surface mount. It's not old through-hole components. Also, this is an amateur transceiver, so there's parts can be really tight and compact. They can honestly be a royal pain in the butt to work on because stuff is so crammed in the cabinets of these radios. And when you get into mobile radios, they're even worse because they're taking basically the same thing and cramming it into an even smaller, box basically. But when you're working on something like this, you don't want to be using your granddad's 50-watt Weller soldering iron, big pencil iron, or 150-watt gun-style soldering iron. You want to use something that's appropriately sized for what you're working on. And surface mount parts are extremely small, so you should be using a very small soldering iron or a more modern soldering iron that has a very large assortment of tips. You just want to use a small tip. So, like the soldering iron I use, here's my daily driver. I've got several of these things over there, but I have different tips in them. But they're very easily replaced. I just loosen the set screw, pull the tip out, and I can just slide a new one in. But if I'm working on something like this, and I'm going to be doing very small, probably 0402, 0603 size components, I'm going to switch to a much smaller tip, something like this, very small, compared to that big, gigantic chisel tip that's right there. You want to use a tip appropriately sized. The other thing is, you want to be careful where not only the tip of your soldering iron is, but where the rest of the soldering iron is, because anything metal here gets hot. The only thing that doesn't get hot is stuff that's inside of insulation, the handle and whatnot. And that's apparently what happened to this. He soldered a bridge across the points on the board to do the Mars modification, but laid this part of the soldering iron, from the looks of it, down on that ribbon cable, and yeah, it didn't do so well, because needless to say, they're not heat resistant. So let me pause the camera here, I'll get the bottom cover pulled off, and we can take a look at this. He'd actually sent me a picture of it, but we'll get the bottom cover pulled off and take a look at it and see. Okay, so here we are on the bottom side, and yeah, sure enough, some of, wouldn't say electric smoke got let out, but some plastic smoke definitely got let out. So I get down here as close as I can. Focus, focus, focus. There we go. Get a pointer here. So the modification is to solder a bridge at this point right here. And they're numbered 1 through 9. And let me get a little bit of additional lighting here so we can see down in there. There we go, that's better. But you can see how there are 0 ohm jumper resistors on number 6 and number 7. 8 and 9, 1, 2, 3, 4, and originally 5 did not have it. The modification is to bridge across. Now that's all a 0 ohm jumper is. It's in a resistor package, but it just has no resistance. It's not a resistive material. But they're used as jumpers, and it's best to use those. The problem with using a blob of solder is it would take an enormous amount of current to basically melt this solder. If you have a short in a circuit, a lot of times, if you have a problem in a circuit like this, and it's why manufacturers will use a 0 ohm jumper resistor, they may be using it as a fuse. Because the resistor has a, now it's not accurate like a fuse, but it has a wattage rating, and if you pump too much power through that thing, it's going to burn out. But much better to burn out, let's say, a little tiny jumper resistor than to blow out an IC and then maybe several other components in a circuit. So, like I say, I always prefer, if the solder pads, something like this, surface mount, put a 0 ohm jumper resistor in like it's supposed to have. They're very cheap. You don't need to buy an entire reel. You can go to DigiKey, Newark, or shoot even eBay and get, appropriately sized 0 ohm jumper resistors. But that's what you should be using. But yeah, the blob of solder, it's almost shorting out against, the pads on either side there. And the big problem, as we can clearly see here, is apparently when he came in with the soldering iron like this, laid the soldering iron on the ribbon cable here. And yeah, I'm not going to plug it in because I don't know if maybe some of these wire, the filaments in this cable are actually shorted. And I gotta see, let's see, that cable goes from there, I think, to the main control unit. It may be fun getting this cable out of here. It goes up to, I think, the front unit. I'm gonna have to pop the top cover on this as well. Yeah, it's not like I'm replacing this cable where it's easily accessed on each ends. Yeah, this one fishes its way up through the front here, almost up to the top. But if I remember right, I think this is the interconnect cable. I think that one goes to the board on the front chassis here. But I'll get the top cover off and take a look at it. But, yeah, so more screws to take out. And yes, my God, are there ever a lot of screws in a Yaesu? I wouldn't say there's a Googleplex worth of screws, but man, it sure seems like it. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, there's like 8. Well, here, they're right here, as a matter of fact. There's all the screws, and that's just for the bottom cover. So, yeah, if you're going to be doing them, get out your speed screwdriver. It makes it a lot faster. So let me dig into this a little bit farther and see how far I actually have to dig into this to get in to be able to remove this ribbon cable. And like I say, I'm going to clean that off and install a proper 0 ohm resistor. So I shall return. Okay, so yeah, it's not too bad. Take off the top cover. That's what I thought. It went up to the main front panel board here, which it does. So this actually has a hinged front, so it actually makes it fairly easy to service this. You don't even have to take off the top internal shielding plate here. You don't have to take these out. You can see the holes are slotted, but I just removed them. See, those 2 screws, then you'll remove the 2 screws at the top edge here, and then down here a little bit farther, there's 2 more screws that are on slots. Just loosen those screws up. And as you can see, that actually allows you to rotate this down at a full 90 degrees. But this is the cable right here that we need to replace. So let me get that, and I've just got it sitting up on a couple bench cookies here to keep it up so I can rotate this down. So let me get that popped out of there, get the new cable in, get her flipped over, fix that bodged solder blob on there, and I'll get this fired up because I'm hoping the customer didn't try and turn it on like that, because Lord knows what might have happened. That's why I have not powered it up. So fingers crossed, we'll get all that done. We'll do a master reset on this, because anytime you do something like that, you're supposed to reset the unit back to all default settings. So I'll do a master reset on this, and then we can see if it actually works. So like I say, fingers crossed that nothing else happened to this poor thing. Okay, so the old melty cable, or melted cable, has been removed. Focus. Yep. And we're good as new again. So we got new ribbon cable installed, and also removed that huge glob of solder that used to be right here and installed a correct 0 ohm jumper resistor. Like I say, I just prefer using those because that blob of solder that was in there, it would take several amps to melt that blob of solder. You'd need basically a dead short and a power rail before that blob of solder would ever blow, and yeah, you would have destroyed, processors and Lord knows what on a board. Where with a 0 ohm jumper resistor, those are usually only a fraction of a watt. is all it takes, and that thing will go poof, it'll just open up. And so, like I say, I prefer to use those because they're a poor man's fuse, and I believe that's why a lot of manufacturers, you'll see on boards a lot of times, a 0 ohm jumper resistor somewhere where there's no other reason for it to be there other than that. It was probably just being used as a protection device. So let me get this attached to a power supply now, and we'll hook it up to the communications test set here, and we'll see if she actually still works. I'm hoping so. Like I say, I'm hoping the customer didn't power it up with the cable like that, because I don't know. I could check this with an ohm meter, but I don't know if any of these strands may have contacted each other, and yeah, that's the main microprocessor down in there. So we shall see in a second. So it looks like she survived no worse for wear other than needing the ribbon cable there. So I've got antenna port 1 on the back connected to the communications test set. I'm putting out a 50 megahertz upper sideband signal at, what do I have the level at? Minus 115 dBm. And you can see it's receiving. And I've tried it in several different bands. Receives pretty much flat across the entire range of the radio. I started out at 1.8 and went up to 50 megahertz, and yep, seems to be doing just fine. So, and all the modes work. Tried AM, FM, upper, lower sideband, CW. Everything seems to be okay. So, yep, no damage done other than the little cable there. So, just like I say, if you're going to work on something like this, use appropriately sized tools. You don't want huge soldering irons because there's, as you saw in the case of this radio, there's stuff that's really close to where you need to be soldering. So use the appropriate size tips. You should not have if at the scale of the components that are inside of this radio, you shouldn't have a blob of solder on there that looks like Mount Everest. The solder was like what? Probably, if I stacked 10 0603 resistors on top of each other, they wouldn't have been as tall as that blob of solder that was in there. So, yeah, like I said, and it's another thing, you should use a 0 ohm jumper resistor. But, yeah, just be careful. Don't forget that it's not just the tip of your soldering iron that's hot, it's the entire piece of metal there is hot. So you have to watch out for anything wires or other components. So there you go, it's just a really quick video. Yaesu FT-950, just a really quick repair.